I'm welcoming everyone and thanking you all for joining our tech talk regarding the topic BACnet MS. All events can be found on our LOYTEC main YouTube channel, which can be found under the following link, or by clicking the link on our mail signature. Wireshark. For analysis of network traffic, in this case BACnet MS communication, the Wireshark tool can be used. The program can be downloaded under the following link. For more information regarding the handling of this tool, for example, how to set up capture filters, please refer to LSCT number 8 about the topic BACnet IP in English. This video can be found under the following link. Today's tech talk is split up into 4 parts. In part 1, we will introduce the recommended wiring and the BACnet MSTP channel communication parameters. In part 2, we will check the protocol from a near perspective. For example, how the token passing is working. We'll also see the BACnet MSTP statistics page and how, with the help of Wireshark, certain problems can be identified and in the most optimal situation also solved. In part 3, we will investigate problems on live examples, and in the last part, part 4, we will have a discussion round as usual. Part 1. Wiring and communication parameters. The technology behind the BACnet MSTP channel is RS485. We will shortly summarize the recommended wiring. An in-depth review of the RS485 channel, where the signal form is being analyzed, can be found in the 7th episode of our LOYTEC support tech talk regarding the topic Modbus RTU in English. To summarize the wiring, the optimal installation should contain a biasing circuit, for example LOYTEC LT-B4, on the beginning of the line and a 120 ohm resistor located at the end of the channel. The reference mask should be connected between each of the BACnet MSTP devices and the ground of the secondary side of the power supply. Let us now check the configuration parameters of a BACnet MSTP channel. Every BACnet MSTP network has a unique network number. If the BACnet MSTP channels are interconnected with each other, for example through the usage of a router, then the uniqueness of the network number plays an even bigger role. This number can be configured in the parameter network number, which is only available on BACnet router devices. MSTP node number defines the node number of the device on the network. We'd recommend setting up each network device node number in an ascending manner, leaving no gaps. Baud rate must be the same on every device communicating on that trunk. Per default, it is configured to 38,400. Maxinfo frames defines how many frames can be sent before the token has to be passed on to the next device. Per default, this value is 1. Devices with a higher network throughput, for example BACnet router devices, are recommended having a higher number, for example 20. Max master. This value defines the highest node number of a device in the network, which can be a MSTP master. Per default, this value is set to 127. Misconfiguring this property can lead to unwanted behavior on a bus. An example of this will be seen later on. And the last parameter, network timing. The default is standard. This parameter can be configured to, for example, slow when there are slow responsive MSTP devices on the bus. Part 2. Token passing, BACnet MSTP statistics, and Wireshark. Token passing. We will now take an in-depth look on how the token passing in BACnet MSTP is working. The technology uses tokens to allow master nodes to communicate. This means as soon as an MSTP master node owns the token, it can send several frames to other devices until it has to pass its token to the next node. The max amount of frames a master node can send is defined by the parameter maxInfoFrames. If due to some circumstances the token is lost, The node with the smallest MAC generates a new token. MSTP slave nodes can never initiate a communication, can therefore only answer to requests of any master node. On our device's website, you can find the BACnet statistics page. It can be found under Statistics, BACnet MSTP. On this statistics page, you may find interesting counter which could help giving an overview of the health of the bus. Up here you have the status with the information token OK. This means that the tokens are passed from and to this device, and the communication on this layer should be working fine. Obviously, there's a distinction between the application layer and the network layer. Assuming that there would be no other master on the bus, or the communication isn't working due to, for example, wiring configuration problems, you would most likely get to see the status sole master. In the tab Bus Overview, we get to see the health of the bus in the last 60 seconds. At an interval of 10 seconds, we get to see the indicator health, which is calculated through the indicator token passes, token misses, and token retries. Load, indicating the total load of the bus, calculated through the received tokens, postponed, and PFM, which means poll for master. How the counter poll for master has an impact on the bus load, we'll see later on with Wireshark. Round trip indicates the time packets need to go from and to the node. And finally, the indicator token per device per second. On the bottom of the statistics page, there's the tab Token History, where we can see between which nodes the tokens are passed. Based on that, we're able to see the nodes with their respective node numbers and how the tokens are passed between them. The asterisk next to this node number indicates our MSTP device. How to set up a remote interface. The remote packet capture functionality can be activated on our LOYTEC devices by navigating to Config, Port Configuration, and then the used Ethernet port. In our case, it's Ethernet 1. And here, just activate the functionality by activating the checkbox. And I would also recommend to set up an authentication for security purposes. If you're done, simply press the Save Settings button. A restart of the device is not required. From here on, the remote packet capture functionality can be configured in the following manner. Navigate to Capture, Options, then Manage Interfaces, Remote Interfaces, click the plus button, enter the host and the port, and input your credentials for the web UI of our device. With this information, the Wireshark will be able to connect to the remote host. If this was successful, you will see the remote host here in the list, and then you can press the OK button. Now that we've set up Wireshark, I can show you, as mentioned earlier, what happens if the parameter poll for master is misconfigured. I've changed the max master parameter on our LOYTEC device to the default value 127. What we can actually now see in Wireshark is the following. On the column Source, we have our device with the node ID 1. On the column Destination, we are seeing which device our device is trying to contact. For example, here. So what actually happens is that our node is trying to contact other BACnet MSTP master nodes up to the node ID 127. Since no reply is coming back, it just keeps contacting nodes n+1, which leads to an undesired higher bus load. Part 3. Examples on how to identify and analyze problems in BACnet MSTP. Let us now check an example on how to debug network problems. Assuming we've just finished setting up a BACnet MSTP network by configuring the necessary parameters according to the documentation and connecting the bus to each node. But when performing a BACnet network scan, no devices can be found. What could be the reason? With the help of the BACnet MSTP statistics page, which can be found under Statistics, BACnet, and then MSTP, we could try identifying the problem. The first aspect we could take into consideration is the status sole master. That could implicate that either our LOYTEC device is the only node on the bus with master capabilities, or that due to some cabling issues, we do not have any communication to other devices on the bus. Noticing other statuses, we can see there's actually no token passing going on. However, the counter reply timeouts counts up, which means that there is no answer to our device's request on the bus. Focusing on the transmit side, we can see that the node is sending out data packets, which seem to be polled for master. It's therefore actively seeking another master node. However, checking the receive side, no packets are actually coming in. Scrolling down to the token history, we are seeing that no token has been passed at all. As a conclusion, we can see that either some network parameters are not set up correctly, therefore I'd recommend verifying the uniqueness of the node ID and the correct setting of the baud rate, or if that has been already checked and the communication is still not working, then as a next step, check the wiring and make sure it is cabled as recommended earlier. Example number 2. Selected LOYTEC devices can concurrently communicate via BACnet MSTP and BACnet IP. When both of these ports are activated, they automatically also act as a router between MSTP and IP. We're now taking a look what problem in this regard can occur in the network and how to solve it. Let us assume we have this IP subnet 192.168.4.1. On the right side, we have a BACnet MSTP to BACnet IP routing device with the IP address 192.168.4.206 and the instance number 19,000. Attached to this router are two BACnet MSTP devices with the instance numbers 19,001 and 19,002. On the left side, we have a BACnet IP device with the IP address 192.168.4.203 and the instance number 30,000. On this device, we want to scan the data points of the two BACnet MSTP devices. In our links configurator tool, I'm already connected to the device with the IP address 192.168.4.203, which is the device where we want to perform the BACnet network scan from. Under Imported, BACnet network scan BACnet network, I'm going to filter to the instance number which I'm trying to find. But after performing a scan, the device is unable to find these devices. What could be the potential problem? Let us navigate to the BACnet statistics page. Then to the tab MSTP. So what we're going to do first, we're going to check the tokens if they're okay. The status indicates that the token is okay, so we're not a sole master on the bus. The tokens are passed, and there are actually packets being transmitted and being received. Also, the bus history looks fine, so there are no token missed or retried. So this lay on the network side should be fine. Also, on the token history, we can see our token being passed from our two nodes on the BACnet MSTP bus. Since the network layer looks fine, I'm assuming there's a problem on the BACnet application layer. In LSTT number 8, regarding the topic BACnet IP in English, we have checked the ports page. This page could be used to identify problems within the BACnet application. So what you can check here is the packets which are being received and transmitted, these unconfirmed requests, they look fine. Then we have the whois, so finding the devices on the network. And going to the bottom of the page, we can actually see one counter which is counting up and could potentially indicate a problem. It's the counter reject message to network. To find out more information whether this could be the problem, we would need to use Wireshark. On my device where I want to analyze the network from, I've already activated the remote packet capture capability. So in Wireshark I just need to add the interface. On the remote interfaces, G06. So in this case, I would need to use the network analyze capability, and I'm going to filter after BACnet. And adding my device to the IP address capture filter. Right now we're not seeing any packets. I'm assuming this is due to our BACnet IP port not being configured on the default port 47808, but on the port 47813. To solve the problem, we're going to remove the BACnet capture filter and look for UDP packets using the port 47813. For example, this packet right here. Opening up the the context menu, we can define to decode these packets as BACnet packets by using the BVLC entry. I've defined the capture filter to only filter BACnet traffic coming from these two IP addresses. So what we're going to do now is we're going to try to discover the device once again. So we have just sent the whois, which is an unconfirmed request, to the broadcast IP address of the subnet. And actually the router device, where our BACnet MSTP device with the instance number 19001 is sitting on, is sending a reject message to network. If we actually check the building automation and control network NPDU of the packet with the IAM, we can check the network address, which is the address of the MSTP bus of that device. It has the address 5. And if we check the reject message network packet, we can see the reject reason other error and the destination network address 5. So what actually came to light is that our BACnet IP device, where we want to scan the other BACnet MSTP device from via the BACnet IP router, also has an active BACnet MSTP configuration, which by chance uses the same BACnet MSTP network number. This leads to the router rejecting our message to the network. Summarizing, the problem is that in BACnet two interconnected networks with the same network number cannot coexist. They need to be uniquely identifiable. This is now the end of the presentation part, and I'm welcoming you all to our discussion. Feel free to ask any questions or wish to share one of your experiences regarding BACnet IP.
So hi, Simon from Race. I will have a question um, regarding this configuration. How would be the best way for this to work? For example, you have a links and you have a MESTP channel working, and then you would have IP BACnet simultaneously working. And imagine that you need a second MESTP network. You would add a router. How would you configure all of this, and um, how can we configure the network number for each BACnet network for everything to work okay?
So basically, what you need to have is you need to have unique BACnet network numbers, right? As just mentioned, the LSTT, and so that is the one point you need to make sure of. So because other than that, the routing function is active per default, and yeah, other than that, the whole configuration actually regarding the BACnet MSTP side is done via the WebUI, and then the data points, are then scanned via links configurator.
So maybe good practice is start with one on the IP channel, and your MSTP channels then are 2, 3, 4, 5, 6, something like that.
I find that when we have many devices on a network, and then, for instance, we need to add another one, if we browse the device or browse the network and then the device, it gets very slow. Sometimes I do something like I create a new project, and with an empty links device, browse those devices, get those variables, and then copy paste to the previous project. It is faster than discovering the device and scanning. What are your thoughts about that?
But you're then on a separate network, right? So you're scanning through through a new MSTP strung, or so not on the same network, right?
No, in the same network. Imagine that you have 40 devices. Okay, they are working okay, and then you need to add one that is different, and I need to scan. But as the MESTP is working, the links scan feature gets very slow.
Yeah.
And what I do is a new project. I scan the device that I need, and then I copy paste the points to the old project.
Yeah, I see. I mean, in this regard, I mean, maybe the network is just too congested in this case. I mean, you could try working with the CV deltas, so you do not have that much traffic. And what I've actually personally seen is that on the WebUI, you can configure this APTU length, right? And if you, for example, set it to 206, which is the default value, you could set it up to 480 for BACnet MSTP to BACnet IP routing. And this should actually speed up the scanning process in that regard. So that's what I see often with other customers.
What I also could imagine here is that it could be an issue when you leave the max info frames for the links controller to 1, then you might have a problem, because when you say you have 40 devices, And these 40 devices, they're all passing one token to the next, to the next, to the next, to the next. And the links controller needs to wait until it gets the token, and then it's only allowed to send out one request and gets one response, and then he needs to get the token again from going through the whole line of 40 devices until it's allowed to send out the next packet. So especially the scan can take quite long because of this, because it's only allowed to send out one packet. So maybe in that case, it would help if you increase the max info frame number, because when you set it to like 10 or 20, then the links would get out 20 requests before it needs to pass on the token, you know, that could help. And this token passing is also the reason why, like you said, you have a project that is working fine, and after some time it's getting slow. This can be because if only one device or a few devices fail or do not respond fast enough anymore or whatever, then you have the problem that you are passing the token from one to the next. And then if one device does not respond, then the token gets lost. So the device tries to give the token to the next device. It sees that the token is not passed on. So it tries it again, and after, I don't know, 3 retries, somebody needs to regenerate the token because the token is just lost on the network, you know, it's dropped. And this, of course, slows down the whole communication. If every node is responding fine, then you just, one gives the token to the next, to the next, to the next, to the next, and then this works fine. But if there are only a few nodes that are not passing on the token, then this slows down the whole network traffic. And I think this is the case. And if you have these issues, then you can just check on the statistic pages, like Hans said, then you would see that the token is lost and that this is the issue.
I mean, there is actually a standard, I mean, more or less standard. I mean, I've seen a sample IDE file on how it's supposed to look. And this is something which then can be considered right, but this would need to be checked why, in your case, the import of the IDE file didn't work. So then we would find out, okay, maybe it's not part of that standard where it's mentioned, or yeah, maybe we can implement that there, but that's something that needs to be checked. But there is actually more or less a template, yeah, on how it should look like.